At night, a bright fire lit the sky. The horizon burned orange as a tower of black smoke climbed high into the air. A long train was on fire, its glow visible for 15 kilometers. People far away could see the intense flames. The fire came from a train full of fuel. It was a very large and costly loss for the Russian war effort. The fuel inside was worth millions of dollars. The train itself was deep inside enemy territory. It was supposed to be safe. Yet the tools used to cause this destruction were surprisingly cheap. 4 small drones had done the job, together costing about $12,000. This story begins with a powerful idea. Small, inexpensive machines can travel far, carry effective warheads, and fly low and fast under cover of darkness. A highly trained team planned a bold, audacious strike, following this train for weeks to learn its route and timing. They chose a night when it would be most vulnerable. This was not a solo mission. Kabul 9 tracked the target, Alpha intercepted comms, Next Group managed counter-jamming, and Ronin flew the attack drones. The distance was extreme. The defenses were layered and sophisticated. The drones were small and fragile. A lost signal, a jam, or a lucky shot could end everything. They were 35 kilometers away, pushing their skills to the limit to prove that distance no longer guarantees safety. The plan was a complex dance of technology and human skill. The attack drones used analog video links. Considered older by some, analog delivers near zero latency. Critical when high speed makes even 200 milliseconds the difference between a hit and a miss. Digital looks clearer but adds delay. Here, instant feedback mattered more than HD. The team was a symphony of specialists. Success depended on flawless coordination. Kabul 9 tracked the fuel train for weeks, mapping routes, schedules, and dwell times. Alpha Unit provided electronic overwatch, intercepting Russian chatter for early warning. Next Group readied an electronic battering ram to clear a path. Finally, Ronin pilots would guide the FPVs to impact. The core force, 4 FPV quadcopters, modified hobby platforms, not million-dollar systems. Each carried an RPG-7 warhead, a shaped charge able to pierce a fuel tanker's steel skin. Total cost, around $12,000, risking a $3 million asset. Ronin pilots log hundreds of simulator hours, practicing blind flight by timing and memory. They learn to read static, feel the drone's movement, and react when instruments fail. That training was about to be tested against a gauntlet of electronic and physical defenses. Analog video signals are immediate but fragile. They degrade over distance and are vulnerable to jamming. To overcome this, teams used repeater drones, flying radio towers in the sky. The repeater catches the weak feed from the low-flying attacker and relays it to the operator. Ukraine never relies on a single repeater. 1 main and 2 backups extend range and resilience. They fly different altitudes for range, stealth, and survival, spaced about 2 kilometers apart. A single missile can't knock out the whole chain. The train was 35 kilometers behind enemy lines, beyond typical FPV range. The drones flew through hostile radio waves and layered air defenses, connected by a fragile electronic thread. They used every trick and all their training to keep that thread from breaking. It was a tense route. Resilience and redundancy turned the impossible into merely difficult. Grainy or not, the link held as they approached the storm ahead. At 25 kilometers from launch, the lead drone entered an electromagnetic storm. The video didn't just degrade, it disintegrated into static, then black. A JTEL jammer flooded the spectrum, creating a vast no-signal bubble. The operators began frequency hopping. Even powerful jammers have millisecond-long gaps. 3 quick hops across common FPV bands to confuse, then a mapped gap for a 2-second update and correction. For 15 seconds, the drone flew nearly blind. GPS and GLONASS were spoofed. Even satellite signals lied. Pilots reverted to basics, counting seconds, tracking the sun, navigating by instinct and memory. 3 more drones followed, spaced 30 seconds apart to trace the path before Russians adapted. Next Group fired a 30-second electronic battering ram, brutal but calculated. At 28 seconds, they cut transmission and moved before artillery could respond. The gamble worked. The feed returned, distorted but usable, and the rails below offered perfect unspoofable navigation. Manual mode, no GPS, no autopilot, just vision and reflex. As the drones pushed deeper, the operators made a bold move. Next group activated its counter-EW array, projecting a focused beam to burn a corridor through jamming. It made them visible to every Russian sensor. An enormous but calculated risk. Intelligence showed artillery took about 45 seconds to respond. 30 seconds of exposure was survivable. At 28 seconds, they shut down and relocated as shells likely rained where they had stood. The feed returned, barely, but enough. The team switched fully to manual control. The train was 10 kilometers away, and Russian defenses were fully awake. The first repeater had been destroyed. The backup at 200 meters kept the threat alive with degraded quality. Grainy video, but enough, proof their layered planning bent without breaking. The drones pressed on toward tankers loaded with diesel and aviation fuel. The lead drone flew on, its signal a fragile thread through chaos, holding just long enough to reach Wall 2. The drone's faint electronic signature was detected. Krasika 4 likely picked up control signals and relayed targeting data. A nearby Pantsir S1 locked onto the lead drone, 8 seconds to intercept. 6 decoy drones, each around $200 and fitted with corner reflectors, appeared as massive radar targets. The targeting computer couldn't tell real from fake, engage all or risk letting threats through. The operator fired. 8 missiles roared, 4 decoys malfunctioned. But the ruse worked. The Panzer wasted most of its ready arsenal. Only 4 missiles left and a 20-minute reload. The real attack drones went low, 10 meters high, 80 kilometers per hour. The Panzer's radar struggled at treetop level, confusing targets with clutter. Trees, rocks, debris. They had slipped under the radar. Literally, the primary wall was breached. Decoys bought time. Terrain hugging bought survival. The rails, and the target, were now within reach. Flying so low presented new dangers. Power lines nearly invisible through static. Trees, radio antennas, even birds became lethal obstacles. One hesitation could mean a crash. Ronin pilots weren't relying on sight alone. They memorized every inch. Power lines at kilometer 27, a radio tower at 29. Krasika still tracked the analog signals but couldn't kill them. Analog fades, it doesn't die. Even with heavy interference, pilots could see something. A digital feed would have gone black. Choosing analog proved critical to the entire mission. 4 kilometers out, the train received a warning. The engineer pushed throttle. The whistle screamed. A moving target slashed the chance of a hit to around 30%. With 3 kilometers to go, Pole 21 fried navigation. GPS and GLONASS vanished. Even the magnetic compass spun. Only analog video held. Blurry, static, distorted, but there. The pilots followed the tracks like a road through chaos. Now the strike would be decided by timing, discipline, and instinct, under a collapsing feed. The final approach was a masterclass in controlled chaos. The pilots were flying almost entirely on instinct. They counted the train cars as they flashed by. 7, 6, 5. Intelligence said the third car behind the locomotive carried the most volatile fuel. Smoke made sight unreliable. Timing and rhythm took over. The drone screamed over the tracks, meters from target. Then the video began to collapse completely. Pole 21 won the picture. The drone went blind for the final seconds. Training took over. The pilot trusted timing and last known trajectory. 3, 2, 1. At 4:32 a.m., a flash tore across the horizon. Impact. The RPG-7's shaped charge punched through the steel shell, igniting 60,000 liters of diesel. The shockwaves slammed the next cars, locking the brakes and stopping the train. 30 seconds later, the second drone, flying blind, found the fourth car. Impact. The third plunged through heat and smoke until a glint of metal. Impact on the seventh car. The fourth flew into a 100-meter inferno. One intact tanker remained at the rear. The operator dove straight into darkness. 3, 2, 1. At 4:33 a.m., the last strike hit home. 11 cars burned. The line was broken. The last tanker erupted, completing the train's destruction. 11 cars burned furiously. 660,000 liters of fuel fed a 6-hour blaze that warped steel and shattered concrete ties. The supply line was destroyed, out of commission for at least 72 hours. 4 small drones, about $12,000 total, wiped out 3 million in minutes. The real impact was psychological. Nothing is untouchable deep behind the front. 35 kilometers today. 50 tomorrow, 100 next week. No train, no depot. No bridge is beyond reach. Lessons. First, low-cost accessible tools can have strategic effects. A small drone can defeat a multi-million-dollar defense. Second, human skill and training matter more than ever. Memory and instinct win when tech fails. Third, teamwork and meticulous planning, not luck, win battles. Intelligence, rehearsal, coordination. Finally, a warning to those relying on long, exposed supply lines, and a signal that asymmetric ideas can reshape battlefields overnight. The age of safe, predictable logistics for Russia in Ukraine was over. Commanders must plan for a world where tiny, cheap tools deliver massive blows. The rule book for warfare was rewritten, not by battleships or bombers, but by operators with laptops and modified hobby drones.